Okay, let's kind of get going here. How's everybody doing? Everybody doing all right? You guys had a good couple of weeks, I take it? Check 1, 2. Everybody there?
Yep.
Okay.
Great weekend. Yep.
Awesome. Okay, well, we might as well just kick right into it here. Obviously, this is going to end up being part B of the first session that we did on Immersive, and we kind of picked up this conversation right toward the end, where we were talking about, all the fill concepts for Immersive versus the other, formats of PA, etc. So I thought we'd kind of, whip through this again. Let's do a little bit of comparison again. You guys saw Scott come into the room, so I'm really glad he's here. He's going to help, kind of validate some of the things I'm saying and answer some questions, probably as many for me as they do for you. Because, the whole concept of doing fills and for Immersive and subwoofers for Immersive is pretty interesting because it's definitely situational, but you definitely have to think a little differently when you're doing it. So, sorry, I'm just doing a little more, letting a few more people in here. All right, so let's get going. We'll have just a really quick review here. So last week we talked about comparing all the different formats of PA systems, mono versus stereo versus LCR versus immersive, and kind of the pluses and minuses of all of that, right? The trade-offs of all of those. So where we ended was just kind of getting toward fills and subwoofers. So if you remember it, we had this was the criteria used to compare all those different formats. We're not going to go through that criteria comparison again today. We'll get through this relatively quickly. But just remember, this was the criteria that we were used for the comparison previously. And then, this is kind of how it all shook out, just kind of, you kind of driving home the concept of trade-offs, right? No one of them is perfect in any situation. It's all a little bit situational, and you just got to pick the best balance of your trade-offs to pick which format you want to use. Obviously, there's all kinds of things that go into that even deeper than what we talked about, but those are certainly the ones we discussed last week. All right, so let's talk immersive fills and subwoofer concepts. All right, so what we were saying was for mono, and typically in a big mono system, doing extension of that coverage and extension of that signal is not too difficult, right? We're just literally in a big center fill. We're just extending that out for delays, and it's pretty easy. We have to have a lot of manipulation of time there. Although if we get these kind of things equidistant, we can use one time there, but it requires the actual physical spacing to be accurate on all of the fills. Short of that, we can do discrete times there and get this pretty phase coherent for the entire space. This is actually pretty easy to do. But once we get to front fill, the same thing applies, right? If we're going to do mono fill down there, that again just becomes that downward extension of that big, mono fill or mono main PA system that we have up. There's no sense of localization here. This is all just time back to a central source. So it's, like I say, it's relatively simple to do, given all the trade-offs that we talked about last week. But once we go to line source here, this is going right, then it gets a little trickier, right, in terms of extending the coverage of that line source, right? We wouldn't necessarily want to build an arc of line source there right above the center. And more often what I've seen is people will do something along these lines where they'll put extension clusters out to the sides there. The same principle applies for the ground fill. Obviously, we're just extending coverage down there, and it all kind of works out fine. But once we start doing the delay fills, then again, we don't necessarily need to do one for every array. We can certainly, but
it would make me feel good about making music. It would make me want to die. And I
mute your mics if you haven't. There we go. I'll get you. And it's just an extension in terms of time. Again, it's just discrete times. Same signal kind of going everywhere, and it's just amplitude and time adjustment to get that right. So again, not too difficult in that situation. It's not a lot of criteria or a lot of decisions need to be made there. All right, so as it says here, M1 and M2 and M ground all require discrete time manipulation, right? We need to have discrete times on them to get them back to that center source and you know, that's the main goal there. Now it gets a little trickier, as you'll see here, when we get to subwoofers, right? So in the subwoofer situation, you know, I've actually been involved in some designs where there's been a lot of discussion of how best to do this. I see this a lot in arenas, you know, for sports, etc. Although maybe now's the take the time to make sure and redefine our context here. Really, everything we talk about today, guys, and I don't mean today in terms of the decade that we're in. I mean in this hour. Everything we're going to discuss in this hour is really revolves around doing this for music presentation, right? For live music presentation. This is not sports arenas. This is not theater, any of those kind of things that are so much more situational than what we're going to be even talking about here today. So keep in mind, we're in a pretty narrow context here. We're looking at this strictly for live music production, okay? Mute your mics, please. Mute your mics. Thank you. All right, so in this situation here, you can see that we have subwoofers flown directly behind each array, which is totally a legitimate thing to do if you want to do it. But you can also make an argument that what is better served here, especially in a big format, in a big arena, is actually a center cluster of subwoofer, and that because you're delaying this all back to a single time source anyway, right? Now, the argument that I make sometimes versus this is that with the center subwoofer system, we're actually creating one impulse and kind of one arrival time for the subs, no matter where you are, right? In this situation, you're creating 3 different sub impulses out into an acoustic space, right? Even if they're timed back, at some point, there's different arrival times for all those arrays, depending on where you are in the arena. And that's not as much the case here. So again, it's kind of situational. You might be able to do it here. You might not be able to. I've had situations, even though we're talking about music here, you know, if you want to go back to the arena for the sports, you know, sometimes the scoreboard would inhibit you doing this kind of center array thing. So you have to go back to the other. So, but in terms of the alignment, it's pretty simple, right? We're going to create one sub array there, or we're going to create 3 sub arrays timed back to each other. Same kind of thinking for the ground fill, right? We can always go to the split left-right stack. I think by now we all know the downsides and the challenges that come with doing that, you know, in terms of horizontal coverage and all the nulls that we create and do that. So, you know, something we see a lot more often today is a distributed ground system. I think in either of these systems, I would always kind of recommend you do complementary band passes here. I wouldn't have them necessarily overlapping band passes here, where you might, you know, have a specific band pass for the flown and a specific band pass for the ground and have them crossed over. All right, so that's kind of what the little paragraph is implying here, that sub F and sub G, sub F being flown, sub G being ground. You know, they require discrete time manipulation. You can do some pattern control in this if you want to, you know, create cardioids or create arcing, all of those kind of things. Those are all just trade-offs against efficiency, whether we want to admit that sometimes or not. I see guys that don't seem to want to admit that sometimes, but once you start arcing, once you start doing cardioid, you know, you can actually affect the efficiency pretty dramatically of your entire subsystem. So, you know, figure out what you want to do there and make sure you're applying the right metrics to get it done. All right, let's see, what do we got next? Okay, let's talk about fill support for stereo, right? Our big left-right PA system. In this situation, you know, a lot of times, at least this is what I've done in the past, I'm just extending that left coverage and extending that right coverage. And I'm maintaining some mix integrity by not putting anything that's critical anyway, very far wide left and right. It's kind of, as I described to Scott, I think last week, it's more of a wide mono as much as anything, but you do have placement capabilities with it, right? You have the ability to have things in the center, out to the left, right, create some space really as wide as you want to do it. In terms of fill, more often than not, we'll see mono front fill for this situation. Very rarely do people put down, a left and right stereo fill here. And kind of the same thing for the delay. Most often delay is done as a monofill out in this situation. Now, it's not to say you can't do it in stereo, but obviously it gets trickier in terms of drive and all kinds of things. But even in these situations, I would even recommend discrete times for all of these mono sends. You want to be able to get that thing coherent in the critical listening zones of any one of those fills or delays, right? We won't go into the concept today of what you're delaying that front fill to. I've actually covered that in a previous lab. If you want to go back and dig it up, whether you're actually taking that front fill and delaying it to the PA system, or you're delaying it to the back line sources. I'll let you guys go back and re-examine that lab if you want to have that discussion, etc. Don't forget, you can chime in at any time with questions if you want to tunnel down on any of this at any point. We can stick around here, so we're not on any kind of time limiter here if you want to discuss. Oh, sorry. So this is that concept of actually using stereo out in the far field, right? So we can do stereo out in the far field for the delays. It's totally effective. It's just a matter of whether you want to do it, whether you want to fly the topology out there to do it. You can also do the same thing for ground fill. I've actually done this in the past. I think I did this on almost all of the Matchbox 20 tours I did, and I really, really liked this. You just had to get the positioning of it right. It had to each of the left and the right ground arrays had to sit in kind of a sweet spot in terms of alignment down there. And I basically, aligned this to the back line, and it was basically two PA systems, a ground PA system and a flown PA system, and I sacrificed the overlap zone out there to make the front field much more coherent for the close listeners here. But this was actually very effective. I did this for a long time. All right, so the flown arrays are in full stereo, as it says here. The ground arrays are in mono unless you want to do them in stereo. You do have to have discrete delays on them, whether you're going to delay it to the PA system or to the back line. Either way. Same thing for those distant arrays. You have to have discrete time manipulation on those to get them in the proper alignment. All right, let's see what we got here. Okay, so let's do some reverse image stereo or some distributed stereo. I see a lot of guys talk about doing this. I'll just be frank with you. It's something I've never been a fan of. I've tried this on a couple of occasions. And never really liked it, where you have both left and right on one side and both left, right on the other. The only time I ever did this and thought it was effective was doing it in the round. When I did some of the stuff in the 80s in the round, we did it checkerboarded, left, right, to the four corners of the stage. And that seemed to work pretty good. You created four zones of stereo, and then the corners of the arena, essentially got one side. But again, that was not really a true... there wasn't anything really, really big stereo going on there. And there was certainly no sense of localization because people were running in circles for the whole show. So, localization was not an issue there. But I have seen this work. And I think probably my biggest challenge with it, or my biggest issue with it, is that it essentially makes the acoustic field mono. Right? When you're standing at the console, especially if those offstage fills are of any amplitude, to compete with the long portion of the hall there, then your pan pot acoustically kind of becomes irrelevant. You can pan something left and it actually goes both directions in the room. It creates ambience on one side and direct sound on the other. So it's kind of a weird duck. I tried it, I think, for a short period of time, and then finally said, no, I'm going to go back to full stereo and I'll just manage it at the mix of what I'm going to do here. So in terms of flown fill, delay fill and front fill, if you're going to do distributed left, right like this, then I would definitely suggest, mono fills for that kind of thing. And really, again, whether you're doing it to the back line or to the PA system, that's an argument for another day, but you want to have discrete times on those fill systems. All right, so flown arrays are in acoustic mono, essentially. Ground arrays are in mono. Delay arrays are typically mono in this configuration. All right, let's see where we go from here. yeah, let's talk about subwoofers in this situation. And we'll just leave it at traditional left-right here, right, where we're discrete left and right. So obviously everybody's seen us do this. We're going to do flown subarrays behind or near the main arrays, and obviously get some good phase through crossover with those two arrays and have it be really, really good. But we're also going to add subwoofers. And again, I know this is going to be a little bit repetitive because some of these are the same, but obviously you can go to a left-right stack here and keep this pretty coherent vertically. But you have all of the comb filtering capability or possibility in the horizontal domain. And, to make sure we're all saying the same language here, that horizontal comb filter is there for the flown arrays as well as the ground arrays. It's not just something magical about ground arrays that give us that horizontal comb filter. That happens in those flown ones as well. So, that's, again, that kind of drives back all the way to our original discussions last week of why this is so unique in large scale format PA systems where we have, the possibility of cancellations all the way down into the subband, even from the left-right PA, because of the spacing, right? Because of the distance that they are apart. They are susceptible to that comb filtering that's happening there. So, what we'll do sometimes is, a lot of times is actually do distributed subwoofers, create, and we can create arcing, we can create cardioid, whatever you want to do here. But the idea is to, clean up that horizontal response of at least that ground system, so it's not so apparent when we're walking left to right or hanging out left to right. Right, we want to get that as clean as we can possibly do it, and then probably the best results I've ever gotten with this, if I'm going to do flown and ground, again, is to do complementary bandpass, right, where the ground system may actually do a lower section of the frequency response than the flown subs, like give them their own piece of the subband to do, and the alignment is easier. They don't conflict with each other out in the acoustic space, et cetera. You can get away with a lot more if you do that in those systems. All right, let's talk about some LCR. And last week we were talking about 100% divergent LCR, so we'll keep it there for this discussion as well right now. In this situation, obviously, we've got separate signals for the left, center, and the right. Remember, the big advantage there is, being able to create localization, try to offset some of that comb filtering between the left and right, because there is no center information being created by the audio out of the left and right. They're more discrete. Anything that is pan center is only coming out of that center array. But in this situation, if we need to expand coverage around there, it gets a little trickier, right? Then it almost, demands that you move back to, 50% divergent, where if I have something pan center, it's going to all three arrays equal energy there. So in that situation, you're almost commanded to do that in order to get around the sides there. Although I'm going to talk about an alternative here that I've been kind of pondering for a while now, and Immersive has made me think this way. So let's talk fills here, though, for a second. So in terms of delay fills, here we can create the image again, extend that imaging out into the far field. That's not a problem. We can do that very effectively here. And again, we can do this regardless of whether it's 50% divergent or 100% divergent. I don't think I would run separate divergences in far field versus near field like that. I think I would keep it the same. I would want those to be the same, but obviously you have to have discrete times on all of those drives out to those systems. Okay, so let's talk front fill now, I think. Yeah. So the times that I've been out with LCR, even when I was doing it 50% divergent, I would actually recreate the LCR image at the ground as well, because I was really trying to create localization there as well. So, the keyboard player that's on the house left would actually appear there in the PA system, whether it was flown system or ground system. So I did that and felt very successful with doing that. I really liked doing that piece of it. If we were going 100% divergent there, then it puts a little more pressure on that center coverage. You have to have some wider center coverage in that ground system if you're going to go 100%. So, and I never did that in the LCRs that I did over my 10 or 15 years of doing it. I was just doing, standard arrays across the front there, but primarily because it was 50% divergent, right? All right, let's talk about, so I'll let the paragraph read out there and I'll grab a drink. All right, so let's talk subwoofers in LCR. Really, same kind of concept, really identical concept to stereo for all intents and purposes. Although I might do this a little differently given a situation I'm going to bring up here in just a second. So same sort of thing where we want to get rid of the splits on the floor and do a little more distributed. We'll sacrifice maybe even a little bit of efficiency there to be able to do some distribution and some better horizontal coverage. That feels like a good trade-off to me especially as powerful as subwoofer systems are today. To sacrifice a little efficiency there to get some better horizontal coverage seems like a good trade. So same sort of deal there. So this paragraph reads essentially the same as the one in stereo. How are we doing so far? Is this making sense to you guys? Is there any revelations for you so far? Man, you guys are a quiet bunch today. You must have partied hard on the weekend or something there. Or maybe I'm going nowhere here. All right, let's talk about...
I was applying some of this to, either full stereo with delays that I've done. For me, it's mostly been corporate since I've been thinking about it. But we've had clients that wanted a full stereo down a whole ballroom. So we had full stereo, 5 delay rows deep. And... yeah,
I've mixed on that, honestly, and that can work.
Good. Yeah, it's pretty cool. The thing about I was thinking is a lot of that has to do with, or in the round type examples, or partially in the round, is creating at least movement, if not, more than localization, just so you can get people kind of, altering their space a little bit.
Yeah, I think in the far field, I'm not as worried about localization as I am just spatialization, so to speak. And I don't mean that in the strictest sense that we'd use it today, but just getting some things out of the center and getting them off to the sides a little bit can make it a little easier to mix it, live. Just you're not so tied down to that concept of stacking a lot of instruments and voices in kind of front to back there to get them to read, All right, let's see. Where are we at here? All right, yeah, we're going to talk about... oh, this is what I was going to talk about, yeah. So, kind of given what I've, I'll say learned, I guess, or discovered in the last little bit of time here over, dealing with immersive, certainly through talking to people like Scott and, I saw Hugo Laren in the room today talking to him about how spatialization works, and as well as other people. It really made me start thinking about how I've done LCR in the past. And I think, this, as I'll say here, you can kind of file this under hindsight. I think if I had it to do all over again, I might go back and do LCR differently than I had done it in the past. Because I think we could probably deal with some of the situations that I've dealt with, the challenges in the past. So it basically would look like this. If I was going to use Anna to do this, EAW Anna, I think I would try something like this and see how it works. Meaning, a more powerful center array that is equal in terms of height, etc., probably to the left-right array. But the wraparound arrays on the outside, I think I would make mono. And I think that would give me the proper amount of coverage, but also give me the right amount of discreteness LCR down the main throw of the room, right? This would be 100% divergent. So kick, snare, bass, vocals is all in that center array. So it's all dreamland right now. I have no idea whether it would work, but from the experiences that I've had with LCR in the past and just the experiences I've had so far with immersive, this feels like this actually would work really, really well. Whether it would or not, I don't know, but that's kind of dream time for me. I would like to go out and try that in some setting. So I think it might work pretty good. I think in this situation too, I would probably even do it as LCR, and I would probably just do it as pure LCR here and let the some of those middle positions, like the left center or the right center positions, be a function of addition between the C and the L or the R. We would still have some, some phantom imaging there, so to speak, to create that positional aspect of it between the LC and the R. So you would be subject to a little bit of comb filtering there, but I still think, given we've cut the overall distance dramatically there between any two arrays that are going to have the same audio, I think it might actually work pretty good. All right, let's move on here. Where are we here? Okay, so now we're going to jump to Immersive, and hopefully this will be the meat of the discussion here today. So as Scott was kind of talking about last week, when you have something spatialized here, obviously spatialization is only going to work truly for a piece of the hall, where you get that the really good localization, the really good acoustic phase, because of elements only, or objects only, exiting primarily one speaker system at a time. So the question becomes, well, okay, let's talk about all the rest of it now. How do you do fills? If we're going to do an arena, rock band in an arena, so to speak, how do we get around the corner, and what do we do with it? What signal does it actually get? Same thing applies for the front fill, right? If we're going to do front fill, well, what signals go down there? Are we going to create a spatialized environment down there as well that is as discrete as the flown? These are all questions that need to be answered. And then in terms of far field, what examples or what situations in the far field are going to exist where we actually want to spatialize, right? I mean, depending on the situation, will tell you kind of whether you can actually get away with spatialization or not there, right? So let's talk about it here. So, the shows that I've seen in this configuration are actually using a mono fill out to the left and right to expand coverage around here. And this is a folded down version of the spatialization. It can, and from what I understand, I'm not going to speak with absolute authority here because I don't have enough experience with it. Maybe Scott can chime in here on it. But you can have the choice of either folding this down into mono, or what is commonly referred to, as far as I understand it, a spatialized mono. It's still a mono signal. All of the objects are exiting that speaker system, but there is delay and amplitude matrixing going on within that feed to give those elements the right placement that is relevant to what's happening out in front of the system, right? So as opposed to a flattened mono, which would just be all of those signals added together and shot right out of that mono system. So a little more care is taken in terms of time and their amplitude in relation to the immersive when it's coming out, this spatialized mono, which sounds very appetizing to me. That feels like the right thing to do there. So maybe I'll just bring Scott in here, and maybe he can help talk through this. We'll go through the next few little bumps and slides, and then I'm going to turn it over to Scott for a little bit.
Hello. Can you hear me now?
Howdy. Good to have you.
Yeah, thanks. Yeah, you're kind of spot on with that. Like, there's two primary challenges. Of course, we've got this beautiful frontal system covering, let's say in an arena situation, maybe 60 or 70% of our audience, but there's still a good third of it that's off to the sides. Yeah. And objective one always has to be coverage, right? That's the first thing we have to do. And that's definitely a challenge to begin with here. Hold on one second.
Scott's got competitors in the background there. That's right. I got him on a day off here.
Sorry about that. That was a 7-year-old desperately needing a juice box.
Let them chime in, man.
Yeah, exactly.
We need to know what they need to think as well.
So challenge one is just coverage, right? So let's just say mono objectively fills that fine, right? And then the second thing we can do is exactly what you were elaborating to, which is how do we ensure it is seamless to the system in front. So that's where we can apply different time signatures to the different feeds that feed it. And that can work, and it does work in certain situations, and it's probably more relevant in some than others. Where there's very little overlap between what will be your fill zone and your main zone, it's probably actually not that relevant, right? Where there is maybe a lot of overlap that's more relevant, and where there is also a wide visual image, it's more relevant. So as we get further and further away from a wide visual image, if we're we're thinking about pairing these together objectively in terms of visual and audio image. If we're on the side, the visual image is a tiny sliver, so it's not nearly as relevant as it is in front.
Yeah. I mean, I'll give you some, practical experience with this. When I'll harken back to this show that I went to see with Lord at Oracle Arena in Oakland. That was my first real experience with big immersive, and I had the freedom to go walk the entire room. I was really curious to how it was going to play out, and I went over to the sides where one of these offstage fills were, and I'll be honest, I didn't realize there was an offstage fill. They had it very well hidden. I was looking, it was dark, I couldn't see it, but I remember standing off to the sides there, and I just could not get past the idea that her vocal, like her image, like if you would have asked me, where is that vocal coming from? I would have absolutely pointed to the center array of speakers, the center main array of speakers. I would have said, that's where it's coming from right now. Even though it wasn't, it was that spatialized, or maybe it was even folded down.
That was a perfectly flat mono.
Yeah,
but that's an example where it's as you pointed out, it's easy or relatively easy to extend the coverage of a mono system, right? Because we're not dealing with a lot of complexity. And in this situation, it was that side hang, the fold down was timed to the arrival of the center array.
Yeah, it makes sense. I mean, I'm not kidding. I stood there for 20 minutes scratching my head thinking, how the heck are they doing this right now?
And the funny thing is you don't lose all the spatialization, because remember, your perception awareness as a listener is dependent on two functions, which is arrival time and the loudest thing, right? So if something arrives first, you can actually have a fairly different amount of amplitude difference between the next arrival. So, let's say 6, 7, 8 dB, the thing can come later and be louder, but as long as that first arrival is first, you still pull to that. And so if we use your example on screen here, Robert, your house left monofill, if we're standing over on the little gray or brown box there, maybe you hear the center just 2 milliseconds ahead of that fill system, but the amplitude or the power is coming from the fill system, but you'll still perceive it all day long coming from that array. That'll actually be true for all the arrays that are closer to you, and all the ones that are further won't be true for, because they'll actually be behind the signal. And so if you think of the guitar player on the right array, that energy would also be coming from the monofill, but would arrive much later from the original source, and so it'll totally disappear to you. And so the part of the mix that is far away will collapse. That's okay as well, because your visual image is small, and you won't really perceive that as a problem. So on Lord, that was purely a mono. And in fact, for most large-scale arena type situations, we're still maintaining that, because there's not necessarily a huge advantage to go to a time-delayed spatial fill for that. Because you don't get any spatialness. You're just getting maybe a moderately better alignment on some signals. So on a really big system, it's going to be helpful. On a arena size, questionable. It might or might not be advantageous.
But no harm in doing it there, right?
No necessary harm. No, not at all. The only issue you ever get into is, has anyone here ever run a delay really fast back and forth on something?
Yes.
Okay, so if you have an object that goes from left to right, and it's maybe got an LFO running on it, so it's giving you that nice effect, the LFO in the front will sound fine because there's no delay applied to that motion across those 5 arrays. But in the spatial fill, we actually have to ramp up and down the delay that's being rendered there. And so you'll actually hear that you can hear that tearing if it goes fast enough. Right. So that's the challenge, right? Because it's the worst case scenario of applying delay smoothing, because you're at a 90 degree to the motion. So we have to apply 20 meters of delay addition and then 20 meters of delay subtraction every, 2 seconds, if that LFO is moving around, with a, quarter of the tempo or something like that. So that could be a problem, right? That could be a challenge that appears in a spatialized system with delay smoothing. And there's 3 ways to tackle that have been done by the world as a whole, the spatial world as a whole. One is to smooth the motion, so don't let it move as fast, or to limit the amount of delay that can be applied in that action, right? So, and you'll see sometimes where things just can't move real fast in certain environments because of delay trying to smooth. This isn't the case in ELISA in all of the primary systems, but it would be in any of the spatialized fills that are doing any delay gain matrixing.
Yeah, that makes sense.
So it's a challenge.
All right. Well, let's jump to front fill here, right? So Same sort of challenge here, I think, which is, do we do a flattened mono down here, or do we do a spatialized mono, or do we just do a duplicate of the LLCC RCR down
Sure.
here? So I got to believe to some degree it's situational, but I'm interested to know what you guys have been landing on, Scott, for guys that are doing this.
I mean, this is where I think spatialized makes the most sense, right? Because you're down and you have a wide perspective. In fact, you have the widest image of anyone in the venue.
Correct.
If you think of it down there, if you're sitting row 3, I mean, you're holding your hands out 120 degree wide is the stage width or more. And so if you can give someone spatialization down there, that's actually really advantageous. The second thing is when you try to create spatialization with gain and delay, you need to have at least 3 arrival sources for it to be really effective to create the localization information. So if you want to create that, I go, hey, I want to feel like it's coming from the left. I need to hear 3 different speakers produce the same thing at different gains and delays. I'm going to then perceive it left versus right. And so basic rule of thumb here is if you want to spatialize fill, you need to have the minimum speaker separation, the maximum speaker separation be equivalent to the minimum listener distance. So front rows at 2 meters from the stage, 6 feet, speakers can be no more than 6 feet wide. Right, so that's your rules. That's easy-ish to do in front fills. It just costs more in terms of DSP amplifier speaker. The good news is, if I were to equate, Robert, if your last tour we took the front fill speaker and applied that to the audio percentage of budget a show, it's probably not a huge number. So if that number gets a little bigger, it's probably not noticeable by most, if not all.
That kind of brings up another point here that's probably worth digging in on. I mean, given that, if we're doing, how do I even want to verbalize this? If we're collapsing down essentially those 5 cents to those 5 main arrays into that monofill or even those front fill, I mean, do they need to be bigger? They need to be bigger, right? I mean, they need to have more power handling capability, I would think.
That's the funniest thing in all of this, and it's the thing that no one conceptualizes until they do their first show, and they don't do this right, which is all of the fill systems that are not spatialized, even if they're like a spatial fill, like a spatial monofill is ultimately still producing all the signals in it. All of those speakers actually have to have the power equivalent of the sum of all of the primary parts.
Right.
So if anyone here likes their Excel sheets, it's 10 log of number of arrays. So 10 log of 5, if I recall, is something like 7.5 dB. And the challenge there is that now my front fill has to have 7.5 dB more power as compared to the signal at any given array. So if you use your center array as the reference and you say, oh, I want my lead vocal to be X loud, you need to have at least 7.5 dB more headroom on top of that, so that when you put the bass player in LC and the keyboard player in RC and the whatever in L and right, and when all of those are getting pushed towards their limit, there's still headroom in the fill. And so what you'll end up with a lot of the times is a very robust looking front fill and a very, very robust outfill, right? So that's definitely a challenge right there.
Mm-hmm.
So yeah, that's definitely something you really need to consider. The other interesting thing is to think about the energy utilization based on music of a spatialized system. So this is something we've done extensive research on, and we've actually taken a power analysis of the amplifier output capabilities of each source in the system throughout the duration of the show. And you can think of the output as a bell curve based on distance from stage, right? Or not even a bell curve, a curve, pardon me. So all the arrays in the center are used a lot, and as you go further and further away, the actual power need is less. So that's good. That tells us obviously how much headroom we need on our fill comparatively to the size of the system, and starts to really hone that in. But definitely that's definitely something to think about. I saw a couple questions come in, Robert. I don't know. It looks like you're answering one of them there. So yeah, spatialized mono or a flattened mono can come from the console. On L-Acoustics land, ELISA land, we can also derive it from the processor if desired. One of the advantages to that deriving from the processor is it applies the gain attenuation that's functional based on depth. So if you use the 3D part of the mix and you go backwards, it'll track that, but doesn't inherently have to be. And you can also derive the mix down range. So this is kind of an interesting part of spatialized mixing. But let's think of a show, maybe we're in an arena show with unlimited budget and we have surrounds. We might not want to put the surround information into the front fills, right? So you could do that on the Elisa processor. You could also do that, of course, on a console and do it as an aux feed, something along those lines. So that would be like 2 ways to do that. But it's something you have to think about is it's not a full mono. It's actually only a mono of objectively certain information that I want to put into this said speaker.
Right. So do you have the ability to filter that in the Elisa processor?
Yeah, you can define the mix down range. So you can define the processor inherently generates a mono LR and an LCR mix down, and you can define its range of use. So hey, let's just keep this to the stage. For example.
Yeah, that range is geometric, right?
Correct. It's polar. Yeah, you define
polar.
Plus minus 45 degrees or whatever you'd say.
All right, groovy. Let's see if there's anything else. Well, I actually see another question that's probably worth addressing here from Winston, talking about what is the alignment procedure, spatialized versus mono. Do you even ever consider aligning to the acoustic sources on a stage in this situation?
I mean, you can, but they're not going to be stationary a lot of the times, right? I mean, I guess like a drum kit's stationary, but how would you do that to a lead vocal if that's your primary objective, since he or she is moving, I would assume?
Well, it's not. I mean, in those situations, the criteria for aligning to the stage is you're picking the most damaging amplitude on stage and aligning to that, and then letting the rest ride, right? So.
Yeah, I mean, the good news is, like, for me, I've always felt in most situations, the front fill alignment I do towards PA, because if that damaging thing is reasonably far upstage, it'll then be early, which will mean my localization information will come from it.
Yeah.
That only becomes problematic when the time difference between the damaging information and the PA is 20, 30 milliseconds. Then it's annoying. If it's 5 or 10, you're kind of in an okay spot.
Yeah.
To answer this question specifically, I've done L-Acoustics breaches. My same scenario here is alignment reference array is center. Right, so in that case, my front fill aligns back to that. If I'm doing a pure flat mono, then each one of my front fill taps will be referenced back to that point. That seems to work pretty well. If it's a spatialized fill, it's done in the processor. So then the processor, you put the geometry in of all the sources, and you have an offset ability, but effectively you're just letting the processor handle the arithmetic of the alignment of each of the maybe 10 or 15 front fills to the 5 or 7 arrays above the stage. So then it'll handle it.
Do those front fills, Scott, do those actually show up in the Elisa processor as individual units?
Yeah, exactly. And then you have to define their source of information. So we could define that group of speakers as the source is the stage, or the scene as we would call it, and we could choose to add other things. So that would be scenario if your next slide happened to be delays, then you could choose for the delays, for example, to have surround information in it as well. If this was a theater, for example, exactly. Yeah. So you could do that. That'd be a pretty expensive way to do it, but you surely could. At a festival, I might not be keen on that, but I might be more so in a theater, since we're.
Yeah, you and I have talked about this in the past. I think certainly in a theater environment where the geometry is pretty narrow anyway.
Yeah.
And I mean, there's a good chance in that situation, if you're doing immersive, people under the balcony are going to be completely shadowed out from the immersive array.
Yeah.
Or if you could support that under balcony, that might make sense there, right?
Yeah, exactly. And that's totally where I think a spatialized delay system makes a lot of sense is in a theater environment or a corporate environment where I can continue that on further and further back. It's an expensive thing to do, right? In terms of, objectively, I could cover this area with 5 speakers, and now I need to do it with 11.
Yeah.
And it used to be 5 speakers on 3 DSP and amplifier. Now it's 11 on 11. Right? So it's a bit different in that sense.
More is more.
Yeah, that's all right.
See, Angelo, I see your question on workflow for channels to output DSP, etc. If you can hang in there, we're going to get to that right at the end of this conversation, and then that will almost be the conversation in total for the next lab. Okay, so hang in there. We'll address that as we can get to it, okay? All right, let's see here. So, yeah, I think I was, I threw this in there as well, where I think you were given the example of maybe a festival or something where you're not going to try to do full immersive in the far field. You would just go back to standard mono.
Yeah,
right?
I think so. I mean, when I think of, doing a Coachella, we've already got 15 delay towers out there. and that's mono, right?
Right.
To go to something reasonable immersive, where we're not going to 20, we're going to 50 or 60 delay towers. I don't know that there's a palette for that, nor do I think it's relevant. I mean, I think when you're 200 meters back, the stage is, even though it's a huge stage, is only taking up 5 or 6 degrees of your visual panorama. Spatialization is not necessarily the first thing that is relevant to me there. It might be more interesting to do surrounds if that's your show and have that cash register bounce around even for the surround people. That might be more interesting than a spatialized front system.
Yeah.
But I think that's production dependent. But I don't see that as the most obvious production win in that scenario.
Sure would be fun to play with.
I'm looking forward to it. I'll be the first one to help design that with you guys if anyone wants to do 50 delay towers. The most I've done is 37, sorry. So I'm looking forward to that.
Nice. All right, let's see. Well, let's talk about subwoofers. We'll get right to this here. Let's see here. Have I done this right? Yes. So I haven't used any automation here. I've just thrown the subwoofers into the system here. So I think at least the systems I've seen so far, you guys are using combinations of ground and flown subsystems, right? Does any of the deployment of that kind of jive with what I've kind of portrayed earlier in this presentation in terms of band passes, signals, etc.? I mean, you guys doing similar things here?
A little bit of, absolutely. I think there's some validity to all of that. One of the interesting challenges you have, so first off, I mean, everyone in the room hopefully agrees that mono subs are the best. And in fact, if we could get it as close to a point source as possible, that's the best. There's a, you brought it up earlier. I think that's a great point. There's a bit of an unwritten, not unwritten, there's a bit of a misunderstood disadvantage of certain sub designs, right? A sub arc is beautiful in terms of its coverage, and it's pretty inefficient in terms of its abilities. That's not necessarily a big deal, as you said, with the powerful subwoofers we have today, except the fact that losing 10 dB or 6 dB a sub is doubling the sub count or tripling the sub count, right? And it's not uncommon to go to a live event and see a inefficient design of subwoofers in the order of 6 to 10 dB. That's actually unfortunately very common. So if we can do it mono, that's great. One of the neat things we have is effectively, let's just think of this at the most simple way possible. A spatial system is trying to create a bunch of mono sources. So if we can keep the alignment of those mono sources all really well, life is grand. So option one might be to have a subsource with each of those arrays. The only challenge there is each of them subsources have to be capable of producing the energy of your single loudest instrument, say your kick drum or your bass guitar. And that means a lot of sub. The second thought is you can't, in a large scale system, put the bass heavy instruments, which are generally rhythmic instruments, very far apart from each other. So it's not really feasible to do that just from a pure time of flight thing. You run into temporal issues in the audience. So they almost unequivocally end up being centered around maybe the center 10 to 15 meters of the stage, or the center 3 arrays ish. So that becomes easier then to place your subs and time it just in the middle. So that's what we've effectively done. The one downside is now if you fly the subs up with the arrays, this is great for time alignment. Everything is well aligned. Everything is impacting. You have good time signature everywhere. You have good summation everywhere. That's all wonderful. You actually have really good coverage as well. You can make the arrays tall enough so you don't have too much energy on stage. That's great. The energy cancellation on stage is consistent. That's great. The only downside is for the people down front, they're missing impact because your subs are now 20 meters away above you as opposed to right in front of you. Yeah. And you're below a vertical array, which means you're starting to get vertical directivity. And the last thing, and this one thing people forget, is the reflected image or the source image from that flown array. When you're standing up on a concrete floor and you're a 6'4" tall guy, the wavelength of the impact, it completely cancels for you when you're right down front because of the bounce off the ground. So you actually get a bit of a reflection from that, and that causes a bit of a notch or a down blow. So I do front fill subs as well, but they're really front fill subs. They're to fill in the first 15 rows or so. And then that's just a sub arc, if you will. So I'm willing to trade that efficiency for that. And I do a different band pass as well, because the PA has that same issue when you're below a large vertical line on a concrete floor of a notch. So I allow the front subs to go up to 100 or 110 hertz, whereas the flown subs, I don't do that. They're only doing maybe up to 50 or 60 related to the infra base.
Right.
The LF come out of the PA. So I do that same thing. That doesn't really help a timing issue at all. You still have an interaction between them. So you'll have one interaction node that will kind of wrap out as an arc, maybe 10, 15 rows out. Then you'll play with that balance of turning up and down the front fill sub and playing plus or minus 3 or 4 millisecond to see if you can mitigate that. But ultimately, you're just pushing it forward 2 rows or behind 2 rows, where those two will fight each other a little bit. But that seems to work really well.
Yeah, it's fun. Subwoofers is always really fun, and I mean the math just works so good down there, and
it's easy math.
If you make mistakes, it's so obvious, so it's fun.
Well, and it's obvious and it's forgiving, right? Like I think people tend to forget that you can change a sub timing by 4 or 5 millisecond. It has a negligible impact on most things. And so sometimes it's like, hey, let's undertime it here by 3, 4, 5 milliseconds, and that's a huge benefit somewhere else.
Right.
Because at plus or minus 90, 5 milliseconds is not a big deal, but at plus 90 to 180, 5 milliseconds is a huge deal, right? In terms of phase response. So you can there's a lot of play there to get away with. But you'll see most spatial systems are doing either if they can fly at a flown center sub, and then the B plan is usually a big sub arc. You're just having to trade efficiency and then alignment, right? You have a vertical issue and you have an efficiency issue.
Yes, indeed. Yes, indeed. All right. Well, Scott, thank you for coming in again, man. I really very much appreciate you contributing here. You certainly have, you have this whole thing kind of dialed in and nailed. It's really great. Nice to have you as a resource here.
Yeah, absolutely.
Anybody got any questions before we move on here? We're going to take our first dive out of speaker systems and kind of set up what we're going to talk about in the next lab here. So I'll just watch the chat. You're welcome to come in with a live mic if you want to ask a question too. That's fine. All right. Okay, so I think we're going to move on here. So let's talk about the next. We'll set up for the next thing. Our next session in a couple of weeks is going to be on object-based mixing. But before we go to that, I want to just kind of lay the groundwork here a little bit in terms of the players that are out there, how they're doing this, how people are actually achieving this kind of spatialization technically and with the gear they're using. So let's just kind of get into this. Oh, I'm sorry. We need to do this as well. I'm sorry. I forgot my wrap up here. I think I got it out of time here. So consideration. So all fill situations, front fill, side fill, offstage fill, really all of it is situational, right? You're going to pick and match it to your situations. Things that can impact this are rigging, sight lines, physical space limitations, and actually what you want to have showing up in this mix. Do we need it to be spatialized or flattened? How does it address competing on-stage sources? All of that needs to be taken into consideration. We don't just want to throw up a speaker and say, there it is, go at it, boys. We want to have some technique and some agenda when we do this, right? And I would say that's not just for spatialization. That's for any situation with PA. In terms of localization and imaging support, do I need to support the main system format? We talked about that right toward the end there. Is flattened mono acceptable? Certainly there are situations when it is. And is spatialized mono preferable? And of course there are times where that is as well. So hopefully we've given you some things to think about and some things to dig in on if you want to find out some more information on this or if you're considering this for your designs. I know I'm starting to see this, immersive systems crop up in a lot more churches now, which I think is a really applicable place for it. I think it's a fantastic solution for these big fan-shaped churches where they're doing this, and we'll talk about the other reason I think it's a good example or a good fit for those kind of places, and that is the implementation of it and how you mix to it. I think it actually makes mixing to it a little easier in that situation. All right, so let's carry on. So these are the players that are currently doing this. Now, this is obviously not everybody. Okay, I'm sure there are other companies out there doing this. But these are the main players, right? So we see D&B Audio Technic, Elisa from L-Acoustics, Spat Revolution from Flux, Timax Sound Hub. The guys in Timax have been doing this kind of work for a long time now in theater. Meyer Sound is now using SpaceMap Go in conjunction with Galaxies to be able to do this. Dolby Atmos, of course, a lot of the mixing concepts, a lot of the object-based mixing concepts have emanated from the Dolby workflows, and they're coming up with and may even have it now, their own hardware renderer to be able to do this. Astro Spatial is another one that is out there that is very popular. A lot of companies have adopted this to be able to build and design spatialized systems using their own PA components. And then, of course, Clang is out there, and it's being kind of deployed. I think it's inside the Digico consoles now. They've partnered up with them to create a spatialized mixing environment in ears, right, for monitor mixing, which is also another place where spatialization could be really, really cool. It's a nice workflow there. Okay, so given that we've got all of these players, there's also a number of different ways that they're going to implement it. And I've just kind of taken my stab at kind of parsing these things out and talking about the way that people do these, way these companies are doing it. And I've kind of broken it into three piles. There's a turnkey system pile, which is the DSP, the speaker system, the amplification system. All of that can be packaged from one manufacturer, really optimized to that manufacturer. And then the second swim lane is DSP hardware. Right, so DSP hardware means there's just a DSP spatialization dedicated piece of hardware that you can use with your own speaker system. You can pick the speaker systems you're going to use with it, etc., and design your system accordingly. That kind of falls under the confines of these three manufacturers out of there. And then, of course, there's DSP software, where you're going to take a computer, and through software, it is going to be the spatializer. You're going to have to hook up I/O devices to it, get input and output through it. But the computational skill or abilities of the computer is going to be put to use to do the spatialization. Now, I mean, let's talk apples to apples here. All of these devices under the hood are computers, but some of them are purpose-built, some of them are not, right? All of the turnkey systems are going to have purpose-built DSP hardware to be able to do this. Same thing in DSP hardware. Those are going to be purpose-built devices to handle the spatialization. In DSP software, that is going to be purpose-built software running on a multi-dimensional computer that can do all kinds of other things as well. But we're just harnessing the power of the computer to do the spatialization. And there are pluses and minuses to all of these. Okay, so from my mind, that's kind of the three swim lanes of deployment and how they look. Let's talk about control now. How do we take control of these devices? And because certainly as the mixer or a system engineer, we got to be able to take control of these devices. Maybe it's real-time control while we're mixing. Maybe it's offline control when we're pre-building. All of these things have to be taken into consideration if we're going to operate here. So the first one is application browser, right? And the vast majority of them will use application browser, right? We'll see a lot of companies that are using, just like a browser window to get into their DSP and take control of that. They'll have a software application, maybe a dedicated software application, but it's all a similar style of control via a remote computer. We also have OSC, which is Open Sound Control. This gives consoles or outboard equipment the ability, maybe if it's even an outboard computer, to take control of elements within the DSP processor, right inside the spatializer. In those situations, maybe a console or another computer that's running audio or whatever can dictate movement of objects within the spatializer or placement of objects in the spatializer. That's all open sound control. Very common language to be able to do these sorts of things. And then the final one is plug-in control, right, where we actually have a plug-in that is running on the console maybe at the channel level that allows us to manipulate an object on the console inside the spatializer, right? So we have some remote control of that spatializer at the channel level via plug-in. So for my money, I've kind of parsed these down into three types of control. So you can kind of see the manufacturers that support either of those. I think all of these will expand at some point. I think, as we go farther along in this, we'll have a lot more consoles and a lot more processors that offer OSC. I think we'll certainly expand the plugin count as well. Most of these manufacturers are in the process of making plugins to be able to put on consoles to be able to take spatialization control from the surface itself. All right, let's talk about our last one, which is 3 road lanes of audio transport. So how do we get audio from the console to these devices? And there's not a ton of choices these days, but they're all very capable choices, right? So in terms of audio networking, the primary sets are Dante and Milan, right? In terms of pure audio networking, those are probably the 2 most common methods I see getting audio to the actual spatializer. We also have multi-channel point-to-point digital, and that's primarily MADI. Right? We can see that MADI from a console to a spatializer either via BNC or via fiber. Either one of those can handle it. And then, of course, digital AES EBU, just single channels of digital out to the spatializer. So obviously we're talking, well, I shouldn't say obviously, but right now we're talking about the potential for large numbers of channels needing to be transported to these devices, right? I mean, you might have upwards of 96, 128, maybe more channels that need to get spatialized, right? So those all need to emanate from the console. So let's take a really quick look at just kind of some signal flow here to see how this would work. So this is an example of a turnkey system. In a turnkey system, we have both a DSP spatializer and a speaker system and amplifier package all maybe from the same manufacturer that are all optimized to work together. So the challenge at that point is, how do we get control of it? Well, we might have a remote computer that is in control of it via browser interface. We might have a plugin that is in control of it. We might have OSC on the console that is in control of that spatializer and dealing with all the objects in terms of their placement and volume, right? In terms of how do we get audio to the spatializer, well, we have multi-channel MADI, Dante, and AVB, right? We can get AVB Milan. We can get any of those out of the console and do these really high channel counts up to the spatializer, right? So that's the example of a turnkey system, probably the most streamlined of all of them that we're going to talk about here. The next one is a third-party spatializer. This would be Astro Spatial would be the great example here, where you can go out to any speaker system that you choose. You have a similar aspect of control here, where you can use browser remote control. As it sits right now, there's not many of the third-party spatializers that have plug-in control available to them, although they are in development right now. In terms of audio transport, again, it's multi-channel MADI or Dante or Milan would be the preferred protocols to get audio up to the spatializer. How about a third-party, a computer spatializer here? This is something like Flux and Dolby Atmos, right? Where the computer is actually doing the spatializing. So then the question becomes, well, how do we get audio to the computer and from the computer to the speaker system? So that's obviously going to require additional I/O devices. You're going to choose your I/O topology there and connect it to the computer via whatever connection scheme is dictated, whether it's Thunderbolt, USB-C, blah, 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 whatever the computer is set up to handle. And then it's a matter of getting control of that. Obviously, control-wise, we're going to be operating from the computer. I know I think Flux now, maybe Hugo can address this. I know Flux now has the ability to control elements inside the computer via OSC. So, there's multiple different ways to control there. I know with Dolby Atmos, you can have Dolby plugins available on your source audio to be able to control that as well. So these are all kind of the challenges that you're going to run into in terms of system design, right? What is going to be right for me? Do I need to implement a turnkey system? Am I going to implement a third-party DSP, or am I going to operate something like a computer system that has I/O attached to it? Those, for my money, those are the 3 main buckets that I see out there in terms of choice, right? Okay, so that's kind of the setup for the next lab, which will be in 2 weeks, and we're going to dive in completely into object-oriented mixing, meaning what are some of the mixing concepts for mixing back to spatialization? How do I handle it on the console? What does it make me do? Like, is there any kind of compromises that need to take place in terms of what I do mix-wise back to these spatialized environments? There's lots of questions to be asked and answered there. And, I think as an industry, we're still really, really early in this, especially for mixing music. We're probably a lot farther along for mixing theater and, even corporate events for what we're going to do. But mixing music is a particular thing back into spatialization. So we'll talk about that next week or in 2 weeks, how we want to go there. So I'll open it up. It's been open for questions the whole time, but if anybody wants to jump in here and ask some questions and start some conversation here regarding any of the stuff we talked about today or any of the stuff that's coming up in 2 weeks, now is the time. Hugo, are you still in the room? Was I correct there? You guys are offering OSC control of Spat Revolution back through the computer? I don't know if he's still in or not.
I am there. What did you say, Robert? Sorry.
Oh, I was just asking, did I see right that you guys are offering OSC control of Spat from other sources?
It's all... Yeah, Spat's been, all about OSC for the longest time. So third-party remote, iOS remotes, obviously, supporting consoles that do OSC as well.
Right.
And as you know, there's obviously a plugin specific to S6 sound. But yeah,
that's right.
It's all around OSC. Yep.
That's right. You guys had, I completely forgot this. You guys had iOS control of that as well. Is that right? And you've had that for a long time.
Well, yeah, the iOS is done, with generic, third-party remotes being Lcr and Touch OSC and Chatting. But I mean, I would actually say I think that the exception would be Dolby. All players, are revolving around OSC for integration.
Yeah.
It's been kind of the de facto, and even add to the conversation that integration with Elisa now is being done with something called ADM OSC, which I don't necessarily want to open the conversation, but it's kind of a common grammar to get an object editor to talk to a third-party renderer. So it's exploding. That concept of external renderer connecting to products together is an interesting subject right now.
Yeah, I think we've literally only touched the surface of it so far. Where we're going to be in this in 4 or 5 years is going to be kind of mind-blowing, I got a feeling. So better to be prepared. Yeah, let's all start wrapping our heads around it now. Anybody else got some comments, observations, anything you want to push discussion-wise?
Yeah, Robert, is Avid going to, I guess, maybe consider redesigning perhaps its output bus topology to better facilitate immersive type mix flows?
Well, I'll lay a little bit of the groundwork for a couple of weeks from now. I actually think we have great options for that all existing today. I think the one place where S6L kind of falls down a little bit is in OSC. We kind of rely on plugin control for control of the spatializer right now. I'm all but certain that once development ramps back up at some point, we will certainly look at moving to OSC in conjunction with plugin. But in terms of just being able to do the object-based, the bus-based mixing, et cetera, that you might want to do in object, I actually think we have some great options for that, and I'm going to cover those in a couple weeks here. So I would just respectfully ask you just to hang in there for that next lab, and we'll talk about all the options of, do you want to be a discrete object, you want to be 96 discrete objects up, or do you want to do a combination of bus mixing plus objects? We'll kind of lay the groundwork for that, where it's very much like film mixing, honestly, where a lot of film mixers will start with a 5.1 or a 7.1 or a 9.1 bed and then support it with objects. It's much easier to manage in terms of handling all these sources. And I think a similar mindset works for music as well, especially for live performance, where you can set up a primary bus and then support it with objects. There's some give and take of it. I think over time, it's probably going to drive some, what I think are going to be fantastic workflows in terms of, linking compression and linking equalization across discrete outputs, things like that. That's all development that's going to take place over the next set of years once the demand for this really starts to happen. But you definitely have to think differently than if you're mixing to a left-right bus. It's just a different mentality, mixing to an immersive PA versus mixing to a stereo bus that's going to be distributed to a stereo PA system. I mean, you think different dynamically. You think differently in terms of placement, all kinds of things. It just makes you think a little bit differently, especially as you start to react to what you hear. You will think differently than you did. I mean, think about. I'll plant the seed here a little bit. Once you're mixing in immersive, what does stereo mean? What do stereo sources mean? What do stereo keyboards mean in immersive? Right? What does that? What does actually mean in terms of placement in an immersive field? So same thing for stereo reverbs. What is a stereo reverb that we might use on a drum or even a vocal? What does that actually mean in an immersive field? Does it actually have relevance there now? Right? Because you're going to have to place that left and right output somewhere as an object in that immersive field. So there's certainly a line of thinking, and I'm subscribing to it now, that stereo, I don't want to call it irrelevant, but I have way less need for stereo versus mono spacing and spatial aspects than I did in stereo. It just becomes way more relevant now. So all kinds of things to think about there. That could end up being a two-parter on the next couple of labs as well, once we start to talk about how to mix back to these immersive speaker systems. So long-winded answer there, Winston. I hope you got something from that.
No, it just seems that to really optimize the spatialization or the object-based mixing, that probably really needs to start back at the console to really take advantage of everything that can give you.
Yeah, I mean, it's almost like you got to train your mindset to think, at least I think this way anyway, that stereo now feels like a limitation, right? I mean, with these immersive speaker systems, I mean, think about it now. We can create as big a soundscape as we want to make, really, with very little penalty. There's not a whole lot of penalties going on in those soundscapes. Whereas in stereo, kind of the bigger we get, the more it kind of falls down in some areas. Its Achilles heel really becomes apparent. And, I said this in the previous lab, that's where stereo really starts to fall apart a little bit for me, is in these large scale stereo, these large format stereo PA systems. In small format stereo, home, theater, car, whatever, those Achilles heels are not there. They're not as apparent because of the spacing of the left and right signal. But you get into big PA system, those are problems. They become a problem, become a challenge. And some of that kind of drifts away with immersive. It doesn't necessarily solve it completely, but it's a trade-off, as I always try to say, of impulse. We're going to trade a little bit of impulse to get some better frequency response / acoustic phase of things. But that in live sound, especially large format, that feels like a good trade to me. So, anybody else? What are we coming up? Yeah, we're almost an hour and a half again already. Boy, these times go by quick on these things. Whew.
Yeah, I got to say, this has been interesting. Where you guys were just talking about thinking of stereo versus immersive, I'm trying to wrap my head around that a little more.
Yeah.
Because that really is going to have to be a different way of looking at everything.
It is.
Instead of, you don't pan your keyboards left, right, and I'm trying to think about the interface now. You're so used to this left, right stereo bus mix, left, right stereo bus mix assignments.
Yeah.
And we're actually upgrading our theater right now, staying stereo, but then I got to thinking in the smaller format, we're doing, with our upgrade, everything is going to have an own amp channel now. So I'm just trying, I know we're not going immersive, we're not getting the immersive processing and stuff like that, but I kind of think conceptually, is there some sort of middle ground that I can do with what I have now without going that far?
Right. Well, that was, honestly, that was kind of what drove my thinking back. If you think back to some of the slides where I had matter of fact, maybe I'll go back to it here real quickly. Is this guy, this is really kind of a halfway ground, you wouldn't necessarily need a spatializer to use this setup. Do I think it would be well served by a spatializer? Yeah, I do. I actually think you could do it a little better with spatialized audio on the left-right monos, et cetera there. But this is kind of an in-between ground. I know Meyer is talking about doing this kind of thing a lot, where they're talking about spatialized LCR. So this would be a good middle ground. For somebody moving from stereo, you could kind of stair step it until you can get to a complete immersive system.
So in this particular picture, how are you deriving the signals on the left-right mono wraparounds?
Well, in this situation, if I was spatializing it, I would probably do spatialized there, right? Spatialized mono, right? Short of that, you could just drive it off of a mono bus on the console, I mean, it's going to mess with the imaging acoustically a little bit here, for certain. I mean, that's one of the downsides to doing that distributed left-right. As I pan left here, depending on the amplitude of the offstage monos, it may mess with my perception of what is happening in the left there. So, you got to be a little bit careful there.
And of course, go ahead, sir.
I was just going to say, but, the LCR portion of it for the main throw of the room actually would be really effective here, I think.
Yeah, and again, that gets a little bit back to thinking beyond left-right panning, too.
That's right.
Trying to think about the whole picture. I mean, as a side note, years ago, there was this little theater outside of Buffalo, the Theater in the Round, that I started working in. We did the left-right, each section, but it was a constant battle because the stage spun.
Yeah.
So as the stage moved, you were, it wasn't just mixing a PA. You were,
Oh yeah, we have a venue here in Arizona.
The back or the front or the sides or like a Fender Twin would spin around, and I mean,
we got a venue here in Arizona called the Celebrity Theater that it has that exact problem. I mean, it's a mono PA system floating around the stage, but when there are a loud rock band sitting on that stage spinning around in circles, man, it's an interesting thing for sure.
But it was a lot of fun too. I mean, don't get me wrong. It really made for an interesting environment.
In terms of the object mixing, though, part of what I was getting at earlier when I was referencing churches who a lot of times don't have the most experienced people behind the console, taking away busing off of the console now, where if I turn up a fader, that direct output is an object showing up in the immersive speaker system, right? So it's just fader up, I hear it. Fader down, I don't hear it. There's way less sense of gain structure because there's no staggered busing. There's no serial busing going on. There's no master bus, other than maybe VCA control, which is just an overall volume control, a remote control of the elements I've got assigned to it.
Right now, the hardest thing I'm envisioning is, and I guess again, it's getting stuck, I think, in the old left-right concept of, when you assign something and turn it up, how do you tell it like where to go, or how does it know where to go spatially in the room? I guess the interface is what's kind of confusing me at this point.
You'll see that in the next segment, but just to give you an example of it, you don't have a pan knob anymore.
Right.
You would have a positioning knob.
Okay.
Right. So, I'll use S6L as the example because I got it sitting right here. So for every channel, you would have a plug-in that is a remote control of the spatializer. Right? And it would only address that object, that fader that you're working with. So you can position it front to back, left to right for that channel on the console.
Okay. I mean, it's similar to the panning concept. It's just taking more dimensions and putting more dimensions into play.
That's partially true, right? Because the thing you have to remember in stereo, and we'll address this in the next session, is there's a down point for stereo, right? When something is in the center, it's either 2 dB, 3 dB, 5 dB down, right? There's no sense of that here, right? You're just placing it left to right because there's no summation really going on here anywhere, right? Between.
Okay.
Right. So, but the cool thing about spatialization that we'll show next week as well is that there is a depth control as well, right? You can push it farther away, and it'll actually use a reverb engine to create that sense of farther away, closer to me. Right. So you do have a second dimension there to place. You have left to right and front to back.
Interesting. This sounds exciting.
It really is, and I mean the times that I've mixed on it, I just thought, oh my gosh, man, this is just going to make live sound mixing so much more fun now. You know, I mean, the options of what you can do are just so dramatically improved. So we'll cover all of that. We'll cover all of that in the next one. I'll actually pull up some front field immersive mixing that we're going to play around with a little bit. We'll talk about stereo versus mono for effects, for instruments, all kinds of things of kind of how to deal with these. And we'll all learn a little bit together because this is new for everybody. I'm still wrapping my head around it, but having some fun doing it. I got an immersive speaker system here that I can kind of pull up and practice with. So
that's fantastic.
I'll share everything I've learned. That's for sure. Okay, let me get out of this. Stop sharing here so we can quit staring at that. And there I kind of am. There we go. All right, guys. Well, I hope you got something out of this today. You know, it was kind of nice to be able to have Scott in here again. Hopefully he'll come back even for the next one. And I can have him, you know, actually even show us some more stuff on the ELISA Spatializer. I hope to do more of this over time. I have plans to do, you know, back through some of these other systems as well. Scott has been generous enough to give me an ELISA Spatializer here to be able to mix back through. We did some presentations for NAM, if any of you guys saw those things. So this will be kind of an extension of that. And then I hope to do some more with Flux, maybe the D&B, possibly even the Meyer SpaceMap Pro, maybe, or SpaceMap Go, I should say. Try to get back through that and kind of look at all these different spatializers and see how they're handling it. So we'll dig into that in the lab as time allows, okay? All right. Anybody got anything else you want to add before we close out here? All right. On that note, I will let you guys all go. We will see you in 2 weeks for the next one that is completely focused on object-oriented mixing. Scott, thank you so much for showing up and contributing. Very appreciated. Same to you, Hugo. Thank you for showing up. If you're still in the room, I appreciate you contributing there.
I am, man. Thank you.
Yeah, thank you. And we'll see you guys in a couple weeks. Take care. Be safe out there. Stay warm.
Thank you, Robert.
Thank
Take
you.
care, and thank you.